And we're going to continue working on this problem, and I figured out that the first angle possible was 32, and then we want to figure out what the angle is in the second quadrant. The second quadrant is 180 minus theta, or 180 minus 32, so that's another angle of 148 degrees. So now our job is to figure out if these angles are possible within the triangle that we have. So first let's check 32 degrees for angle B. If this is 32 degrees, I think that that's perfectly fine because you have 32 plus 45, which gives you 77, meaning that there is 103 degrees left over for that angle. So that's perfectly fine. That works. That angle is okay. I'm going to erase this stuff and check the second angle. Second angle is 148 degrees. Now if I have 148 plus 45, that adds up to be more than 180 degrees, meaning that there aren't any angles left over for this. Actually, it'd be a negative to make it 180, which doesn't really work or exist. So this angle does not work. So because only one angle works, there's only one triangle possible for this question. So now we've seen examples where there's one triangle, no triangles, and two triangles. Okay, so now that's all the questions that we're going to do. This is homework number 103, and it's a worksheet that you have, and it has 7 questions on it. And I think that when I hold things up to this camera that it becomes backwards, but your homework should say 103 on it, and it looks like this. And I know that you can't read that because it's backwards, but this is what the worksheet looks like. So what I'm going to do is, because I don't have a chance really to go over a lot of homework with you, I'm going to spend the next couple minutes going through this worksheet with you. So I'm going to do homework 103 with you. I actually thought that that was the end of the notes for this chapter. There is one more thing that we have to deal with, which is forces and vectors, but it's really quick. It's not that bad. It actually has to do with more parallelograms, and it combines all of the different 3 equations that I taught you. So I'm going to first just go over homework number 103 with you, and then probably go over forces and vectors in the next question, or the next video. Okay, so number 1. Numbers 1, 2, and 3 all say how many different triangles can be constructed. So I'm only going to do homework number 1 with you because we just sat there and did 4 questions together, but I will give you the answers to those questions. That way that you can check. I think I'll give you the answers. Maybe I don't have the answers. I don't have the answers. I'm sorry. But I will do one of them with you. How about that? I know, I'm a horrible, horrible tutor. Okay, so how many different triangles can be constructed given the parts? The measure of angle C is 45 degrees. So I have A, B, C. This is 45 degrees. The little c is 6, and the side length B is 9. So if I'm going to do law of sines, because this is how many different triangles, with law of sines I do sine of C over C is equal to sine of B over B. Okay, so let's see what happens. Sine of 45 divided by 6 is equal to the sine of B over 9. And we're going to try to figure out what B is equal to. Okay, so I'm going to cross multiply and get sine of B by itself. If you want to keep writing out the cross multiplication, that's perfectly fine. But I'm going to do sine of 45 times 9 and then it would be 6 times the sine of B, and then I would have to divide by 6. So sine of B is equal to 1.06, and right away you should recognize that that's not going to work because it's bigger than 1. So angle B, and if you forgot, you'll get an error when you do this. Sine of B does not exist, DNE, meaning how many triangles are possible? No triangles. That's your answer. Your answer is always either 0 triangles, 1 triangle, or 2 triangles. Those are your only possibilities for numbers 1, 2, and 3. Okay, but you do have to show your work. I know that there's not a ton of space on this worksheet, but try your best. All right, I'm not going to do 2 and 3 because they're the exact same thing. Number 4. A landscape designer is designing a triangular garden. So let's draw a triangle, obviously, because we're in trig class and everything is triangles, with 2 sides that are 4 feet and 6 feet respectively. So 4 feet and 6 feet. The angle opposite the 4-foot side is 30 degrees. How many distinct triangular gardens can the designer make using these measurements? So once I read how many distinct gardens or triangles, I know that this is exactly the same. I need to do the law of sines again. This is the ambiguous case, meaning how many triangles are possible. So it's that angle over that side and this angle over that side. So, see, apparently I can't even escape doing these questions. So sine of 30 over 4 is equal to, let's just call this x, sine of x over 6. So the sine of x is equal to sine of 30 times 6. Sine of 30 is a half, so this is going to turn out to be 3. And then I'm going to divide that by 4. So sine of x is equal to 0.75. I don't care what sine of x is. I want to know what the angle x is. So second sine, second answer. Hit enter. And angle x is, oops, there are 2 different options for angle x. My first option is 48.59. So I'm going to call this 48.6. And in the second quadrant, 180 minus 48.6. Hit enter. 131.4. We need to check to see if both of those angles are going to work in the triangle above. So let's check 48.6 first. If this angle right here is a 48.6, I think that we're going to be good because 48.6 plus 30 is 78.6, meaning that I have plenty of angles left over for that. So this angle works. Let's erase that and try the next one. What if this was 131.4 degrees? 131.4 plus 30 degrees, which is the other angle, that's equal to 161.4. So we haven't hit 180 yet. We're getting close, but we haven't hit 180, meaning that this one will work. So my answer to the question is 2 triangular gardens are possible. That was number 4. Okay? All right, let's do number 5 together. Number 5. 2 sides of a triangular pool measure 16 feet and 21 feet. Okay. 16 and 21. The included angle measures 58 degrees, and the included angle is the one that's included in between them like that. So that's 58 degrees. I don't know who on earth has a triangular shaped pool, but that's fine. What is the area of the pool to the nearest tenth of a square foot? Okay, so take a look at my reference sheet because I don't have to memorize anything. Area, K, is equal to 1/2 AB sine phi. And remember with area, it has to be side, angle, side. That angle has to be in between the 2 sides. So in this case, we're perfectly fine, and it works. So 16 times 21 times the sine of 58. That's going to give me my area. I love these questions because you just type it all into your calculator. So this is 1/2 times 16 times 21 times the sine of 58. Hit enter. The area is 142.4720, and it wants the area in the question to the nearest tenth of a square foot, so 142.5 feet squared, because area is always units squared. And that's your answer. Okay, there's only 2 left. Let me check to see how this is going. Good. 2 sides of a parallelogram. So we're dealing with a parallelogram this time. 2 sides of a parallelogram are 4 and 6. The included angle is 60 degrees. It's always the one that's in between the 2 sides. Find the length of the shorter diagonal to the nearest tenth. Well, in a parallelogram, we have 2 diagonals. One diagonal going that way, and that's obviously further apart. That's longer. So this is the shorter diagonal. So we need to find the length of that side to the nearest tenth. Now, I know that this is a parallelogram, but pretty much because you're just looking at this diagonal, we pretty much are only looking at this smaller triangle instead of the whole parallelogram. So we really have a triangle where 2 sides are 4 and 6, and we have an angle of 60 degrees, and we're looking for the other side. Now, if we know side and angle and a side, we can use which of those equations? It's not area. It's not law of sines, because we need to know a lot about the angles in order to use law of sines. It's going to be the law of cosines, which is right here. So remember, if we're using the law of cosines, the side that we write first has to be the one that's across from the angle. So across from the angle, the side that comes first is going to be that x. Okay, so x squared is equal to, and you don't have to memorize this, 6 squared plus 4 squared minus 2 times 6 times 4, and it's called the law of cosines for a reason, because it's cosine of 60. And I love these kind of questions because we're solving for the x right here, so we can plug all the rest of the information right into our calculator. Okay, so 6 squared plus 4 squared minus, and I always just put this all in parentheses, minus 2 times 6 times 4 times cosine of 60. Hit enter. X squared is 28. That means that x is square root of that, which is 5.291, and we want this answer to the nearest tenth, so 5.3 is our answer. There's only one more question left, and it's kind of confusing, so I'm going to stop this right now and then start up another video.